Okay, I believe this is card 8, no, 9B, whatever. I'm not sure, I think. And anyway, there are a couple of things going on here that I want to explain and make sure that you understand. The first thing I want to make sure you do is understand that the number you need to remember with relays is the number 2. All right, and the reason I want you to remember the number 2 is because every relay has at least 2 circuits. Okay, and I drew this way on purpose to show the large wire, which would carry the big amperage, and the small wire, which carries the low amperage. And the number is that this switch may only switch 0.2 amps, which is 2/10 of an amp or 200 milliamps. And the larger contacts might be switching as much as, let me get my face out of there, might be switching as much as 50 amps. Okay, and there are a couple of reasons that this is good. Namely, you can use very small switches to run really big things. Okay, so straight wiring stuff is not always the best decision, and if you know how relays work, then you can certainly use them to your advantage. And they all work the same way, so there's really only one way to hook them up. And once you learn that, then you're going to be a lot better off, and you can go out there and work on stuff. The other thing I want to point out is that the relay is the crossroads of the system. Okay, so the way this is built and the way this is laid out kind of shows that in a rather unusual way, because this circuit here, which is what's controlling the coil, and this circuit, which is going to be running the motor, it doesn't, they don't touch, but they all come together and give you 4 test points in the relay base, right? So here's the relay base. So I've got test points. Okay, so this distance here from the relay to ground through the motor could be 100 feet. All right, and this is probably going to be pretty short, but this could also be 15, 20 feet, say. Okay, well, the cool thing is that sitting on your butt with a cup of coffee, out of the rain, out of the snow, it's possible to test all 4 of these circuit segments from here. Okay, so right here I have the ability to test. Hands are getting kind of full of stuff, markers and stuff. Okay, so I have the ability to test right here. If you look and you memorize here, here's 85, 86. Well, notice in this drawing 86, and this is partially schematic reading, and that's why these drawings are so important. 86 goes to the fuse, so I should be able to read system voltage right here and not guess. And 85 goes to ground through this micro switch, and that's here, so I could read the resistance from here to ground and close the switch and expect to go from infinite or OL to 0. So I'm expecting that to be the case. Well, I should also read voltage at 30. But here's the cool one. I can ohm out the motor from here. Okay, so here's my relay base. And if my 87 goes to the motor, then all I have to do is put my ohm meter in here. And I'm ohming out the motor, sitting on my ass in the cab, not on this snow-covered, icy, wet, muddy, dirty, coal-covered, piece of equipment. trying to find this motor, because here's the problem. What if you find the motor, you unplug it, you ohm it out, okay, or you use one of those, you know, like something like a power probe, and you go, motor runs. All right, well, you know, doing that doesn't do a damn thing for you, because this is only going to fail 20% of the time. The wiring's going to fail 80% of the time. And even if the power probe lets you know that the fault is in a wire, it then doesn't help you find the fault, okay? But just a plain old normal ohm meter, without any special fancy schmancy whatever, you just put it in here in 87 and go to ground. And then when you go to ground, you read the resistance of the motor. Okay? So I'm testing the entire relay system from right here. All right? And you need to pause for a minute and think about this, and think about the way vehicles are built, right? Because there's 30, usually, not always, but usually the voltage for the load. Here's the switch terminal going to the load. Here, in this case, with the numbers I've used, 86 is going to the battery, and 85 is going to ground through the switch. So I can test these 4 circuit segments from here. And the cool thing is, I pretty much guarantee you that only one of them failed. So you have to know all of these correct readings so you can figure out which one's not correct. That's a very simple thing to do. Okay, so this is pretty much how I approach this, and I believe in very simple diagnostics. I don't want to get all complicated with a bunch of expensive parts, you know, and tools that do a bunch of stuff. You can do basically everything you need to do in this system with a relay with the cover off of it and a 9-volt battery, or 2 9-volt batteries. Okay, so first of all, there are 2 circuits. Only one of them probably failed, and I'm going to show you how they work and how we test them, and I'm also going to show you how we can read and understand what's going on. Okay, so there's that. Okay, now when you look at these, the only difference is here. We can switch either the positive or the negative, and it doesn't matter. Most ECMs like to switch negative because the voltage drop allows the ECM to have 0 volts on the connectors instead of 24 volts, which is just safer. There is no major advantage. I've heard all these stories about less arcing, and that's a bunch of crap. I can prove that I can get an equal-sized arc switching either positive or negative, and so that doesn't make any sense. But the most important thing here is to understand that all we're doing is turning on a coil. All right, and just because there might be 5 wires, you can't let that freak you out, because the wires go to terminals, and you know what the terminals are, and you just pick out which one is which. And by the way, if you notice, these 2 wires are smaller than these 3 wires, so 0.2 of an amp here, 50 amps here. Okay, so there's another visual cue. Okay, so the common is different, so it's the common. And this is my normally open, this is my normally closed, and these are my 2 coil circuits. Okay, so what I'm going to do is I'm going to solder a relay in here, and we'll build this, and then we'll come back and I'll demonstrate some stuff for you, and we'll move on. As you do this card, one of the things I hope you will begin to understand is the reason that I say system instead of circuit is because, you know, a circuit is a single circuit, all right? And I'm kind of getting around to the idea that just because something looks like it's connected to the to something, that doesn't mean it's in the circuit, all right? And that's that's a danger when it comes to reading schematics, because it makes the world feel more confusing, and the world doesn't need to be confusing. So if you look at what I built here, I mean, this looks kind of like blah, right? But look at the drawing. It's very simple. Two very simple circuits: power, ground, load, and switch. I mean, that's everything you expect in a circuit: power, ground, load, and switch. All right. That's a circuit. And it doesn't matter what the wires look like. Wiring is not circuitry. Wiring is wiring. Okay? So, you know, this relay could be in the relay panel. This wiring could be, you know, 2 inches away. This could be 100 feet to a big pump motor. And this could be, you know, upstairs or in a big crane, or this could be something as simple as a light switch on your, you know, on your F-150 or your Chevy Tahoe or whatever. It doesn't matter. But the point is that this circuit here, coil circuit, is not connected electrically to the motor circuit. And I intentionally had you guys build 2 circuits to point out that there are, in fact, 2 separate circuits. And if I were to blow this fuse or blow this fuse, then the relay system wouldn't work, but it doesn't mean that one of the circuits one of the 2 circuits is broken. All right. So we've got 2 circuits here and here, here and here. Okay. We've got one load in one circuit. We've got one load in another circuit in the form of that coil. Okay. And I got a little silver marker here. I've never done this before. Let me see if I can do this here. Here's 30 and 87. So here's the normally, let's see if this will work. Here's 87. There's the normally open switch. And then the coil actually goes here. Yeah, you can see that. Okay, so it's the crossway. It's the crossroads. That's the word I was looking for. It's the crossroads of the system. Okay, this is on milliamps. So the first thing I hope I can do, if I haven't blown the fuse, I'm expecting, since I know that the resistance of this coil is about 90 ohms, and my voltage is about 12. I need to charge the battery. I haven't done that yet. 12 divided by 90 is about 0.1333333. So if I'm lucky, when I turn the system on by jumping across this switch, I should get about 0.13333, but it's not through here. Okay, is I'm going to turn on this circuit by jumping across that switch, which is this switch. And if I did my math right, I think it's still on the calculator. No, it's gone. Would be 0.133333 amps. And I have the battery charger on now, so it might be a little higher. Okay. So it is. It's 13333313. Oh. 1333. Holy crap, I got it right. 133333333333. Okay. Now notice that the amperage was going down. And part of the reason is that the coil is getting warm, and that increases resistance, but then also the battery is gradually probably losing its voltage. So that proves that. Well, okay, so that was 0.1333 amps. Okay, so this circuit was 0.133 amps, which is 133 milliamps, which is what we saw. This one, you can't really do it because motors work a little differently than other resistors. I know that if I ohm it out, I get about 6 ohms, and I don't get 2 amps. I get about 1/4 of an amp, roughly, and that's because of the peculiar nature of a motor, which we'll talk about in other cards. But suffice to say that this motor, when it's not turning, is a direct short, but as it starts turning, has more effective resistance. All right, it's not really resistance, but it's called effective resistance because it does slow current down. But I expect this number, put this back in here, I guess. I expect this number to be around between 0.2 and 0.35. Well, yeah, that's pretty much splits it right down the center, right? So there's my 280 milliamps. Compared to 130 milliamps. All right, now that's not a really good example, okay, because normally this motor could be 50 amps, right? But I'm just demonstrating. Notice I haven't turned the relay on. I haven't flipped the switch, and what I'm doing is I'm letting the amp meter do the work for me. Now, admittedly, when I turned on the coil here or here, then the coil is clicking. Now let me show you why I have a compass on my watch. Okay, you can use a compass this way, and this is proving the magnetic field. See the compass needle move? In the case, what I'm doing is I'm switching the ground of the coil, but I'm switching the positive of the motor. All right, because this is my ground and this is my coil circuit. So I could do something as simple as just go here and here, and it works. Okay. If I were to go here, it would blow the fuse. I don't want to do that because I'd really prefer not to deal with that. But anywhere in this system, when I complete the circuit across this switch, it doesn't matter, okay, because I'm completing the circuit across the switch, and that then turns on the coil. Okay. Now let me swap out the relay real quickly, and then we'll be able to see a little bit better, and I'll be able to show you something that I like to show you in terms of diagnosing these systems.